In the first video, we have seen the concepts of the boats and streams, the formulas of the boats and streams. I quickly repeat what we have seen in the previous video, in the first video of the boats and streams. Let's see, if the bike is going in this direction and the wind is blowing in the same direction in which the bike was going on, with the speed of the 50 km per hour and the 10 km per hour respectively, bike and wind. So, it is called as the downstream speed, means when the direction of the speed is equal, then it is called as the downstream speed. So, it is equal to 50 plus 10, as they are going in the same direction, means the wind is pushing that bike which was going with the speed of the 50 km per hour. That's why I make the addition of the two speeds of the bike and wind here. So 50 plus 10 is equal to 60. In the second case, what was happening is the bike is going in this direction and the wind starts blowing in the opposite direction in which the bike was going on with the speed of the 50 km per hour and the 10 km per hour respectively, bike and wind. So this case is called as, means in opposite direction if they are going to each other, then it is called as the upstream speed. It is nothing but 50 minus 10, as the wind is resisting that bike speed. That's why 50 minus 10 is equal to 40 km per hour. Means what we came to know that if the downstream is there, means they are going in the same direction, then we have to make the addition. And if they are going in the opposite direction to each other, means upstream, we have to make the subtraction. So in both and streams, the question will be either we have to find out the speed of the boat in the still water, or speed of the water, or rate of stream, or the velocity of the water, which is nothing but y. So we have to derive the formula of the x and y. As we know that if the water is going in this direction and boat is going in the same direction in which the water is going on, then it is called as the downstream speed is equal to x plus y. X means speed of boat in still water and y is speed of water. So I can call this equation number as a 1. Then if the boat is going in this direction and the water is going in the opposite direction in which the boat was going on, then it is called as the upstream speed is nothing but x minus y. Then I made the addition of these two equations and the subtraction of these two equations. By doing the addition, what I got here is sd plus su is equal to x plus x, 2x plus y minus y gets cancelled here. So x is equal to 1 upon 2 of sd plus su, and here sd minus su. As we are doing the subtraction here, this plus x will become minus x, this minus y will become plus y. So plus x minus x will get cancelled. Plus y is equal to 2y. So y is equal to 1 upon 2 of sd minus su. So on these two equations we have to work on the boats and streams. So let's see the questions. Now let's see the first question. A boat covers 3 km in 5 minutes while going upstream and 600 meter in 24 seconds while going downstream. Find the speed of boat in still water and the rate of stream. Speed of boat in still water means what? X. And the rate of stream means what? Y. We have to find out the values of the x and y here. Now quickly I repeat the question. A boat covers 3 km. Okay, means this is the distance. 3 km means what? 3 km. As we know that 1 km is equal to 1000 meter. That's why 3 km is equal to 3000 meter in 5 minutes. So time is also given here. 5 minutes. We know that in 1 minute there are the 60 seconds. So that in 5 minutes, 6 5s are 30. 300 seconds will be there in the 5 minutes. Now, boat covers 3 km in 5 minutes, means this, while going upstream. This is the case when the boat was going upstream. Okay, now let's see. And we have to find out the speed of the boat in still water, means x, and the rate of stream means y. We know the formula of the x and y, which is nothing but 1 upon 2 of sd plus su, and y is equal to 1 upon 2 of sd minus su. But before solving all these two terms, what we should know the values of the sd and su, and we don't know here the value of the sd and su. For that, all these two terms are given here. So, the second part of the question was, while going in the upstream, all these two terms are there, and 600 meter means again distance is equal to 600 meter in 24 seconds, means time is also given here, 24 seconds while going downstream, and these two terms are while going downstream. Now let's see in the upstream and downstream, and we have to find out the values of the x and y. For that we know the equations 1 upon 2 of sd plus su and 1 upon 2 of sd minus su. But before solving the values of the x and y, we should know the values of the sd and su. So we first have to calculate the value of sd and su. Now let's see. Here the upstream case is here. So upstream speed we have to calculate. We know that distance is equal to speed into time. Now here we have to calculate the upstream speed. Upstream speed is equal to distance upon time. So distance upon time. Here distance is 3000 meter and time is 300 seconds. So 0 gets cancelled. 3 tens are 30. So 10 meter per second is the speed of the upstream. This is the upstream speed. Now in the downstream case we have to see. In the downstream case also we have to find out the value of the downstream speed. So downstream speed is equal to, as we know, the distance is equal to speed into time. We have to calculate the downstream speed. Speed is equal to distance upon time. Again d upon t in the downstream case also. So here the distance is 600 meter. So 600 meter upon time is 24 seconds. So 24. 24 2s are 48. 12 is remaining and 0. And 24 5s are 120. So this is the meter per second. This is the downstream speed. But what we have to calculate here is x and y, these two terms we have to calculate. And we know the formula of the x. X is equal to 1 upon 2 of SD plus SU. So 1 upon 2 of SD is what? SD is what? SD is 25. So 25 plus SU is 10. So 10. So 1 upon 2, 25 plus 10 are 35. So it will become the 17.5 meter per second. X is equal to, means the speed of the boat in the still water is the 17.5 meter per second. Similarly, y is equal to 1 upon 2 of SD minus SU. Again, 1 upon 2 of SD is what? 25 minus x is what? Sorry, SD is what? 25 and SU is what? SU is 10 meter per second. So 10. So 1 upon 2 into 15. So I got here the 7.5 meter per second as y. Means what? The speed of the water or rate of stream or the velocity of the water is nothing but 7.5 meter per second. And the speed of the boat in the still water is 17.5 meter per second. So this was the question. I quickly repeat what I did here is, a boat goes 3 km in 5 minutes. So distance is equal to 3 km. 1 kilometer means 1000 meter. That's why 3 km means 3000 meter in 5 minutes. So t is equal to 5 minutes. In 1 minute there are the 60 seconds. That's why 6 5s are 30. 300 seconds are there. While going upstream. So upstream case is here. And 600 meter. So 600 meter. In 24 seconds. That's why 24 seconds. While going downstream. So this is the downstream case. Now, and we have to find out the speed of the boat in still water and the rate of the stream. Means x and y we have to calculate. And we already know the formula of the x and y. If you have not seen my previous video, please watch the previous video which is of the concepts of the boats and streams. Then you will get how these two equations came here. So x is equal to 1 upon 2 of SD plus SU. Y is equal to 1 upon 2 of SD minus SU. As we don't know the values of the SD and SU, so we first have to calculate the value of the SD and SU. So here in upstream, speed is nothing but we know that distance upon time. So distance upon time. Here distance is 3000 meter. That's why 3000 meter upon time is 300 seconds. That's why 300 seconds. So I got here the upstream speed is equal to 10 meter per second. Similarly, in the downstream case also, distance upon time, downstream speed is equal to distance upon time. Distance is here 600 meter. That's why 600 upon time was the 24 seconds. That's why 24. So I got here is downstream speed as 25 meter per second. But we have to calculate the value of the x and y. So x is equal to, we know the value of the x, formula of the x, 1 upon 2 of SD plus SU. That's why 1 upon 2 of SD is 25 plus SU is 10. That's why 10. So 1 upon 2 into 35, 17.5 meter per second. This is the speed of the boat in the still water. Again for the y is equal to 1 upon 2 of SD minus SU. 25 minus 10 for 15. So 1 upon 2 into 15, y is equal to 7.5. So this is the speed of the water in the still, speed of the water. And this is the speed of the boat in the still water. Now let's see the second question. A boat covers 800 meter in 2 minutes while going upstream and 3 km in 4 minutes while going downstream. Find the speed of boat in still water means x and the velocity of the water means y. We have to find the similar, the speed of the boat in the still water and the velocity of the water means x and y respectively. We have to find out here. Now let's see how to calculate. I quickly repeat what is the question is. A boat covers 800 meter. Distance is equal to 800 meter. In 2 minutes, t is equal to 2 minutes. But we know that the 1 minute is equal to 60 seconds. That's why 2 minutes is equal to 260 are 120 seconds while going upstream. So this is the upstream case. And 3 km. Distance is equal to 3 km. As we know that 1 km means 1000 meter. That's why the 3 km means 3000 meter. In 4 minutes, time is equal to 4 minutes. As we know that 1 minute is 60 seconds, 6 4s are 24. So in the 20 to 40 seconds, while going downstream. So this is the downstream cases here. And we have to find out the speed of the boat in still water means x, and the velocity of water means y. And we know already the formula of the x and y, which was 1 upon 2 of sd plus su and 1 upon 2 of sd minus su, respectively, of the x and y. Now let's see. Before calculating the value of the x and y, which is the speed of the boat in the still water and the speed of the water, we must know the value of the sd and su. So in order to calculate that, what was given here is for that purpose only. So we have to calculate the sd and su. This is the upstream case. So the upstream speed is equal to, as we know, distance is equal to speed into time. That's why the upstream speed is equal to distance upon time. That's why distance upon time. Now the distance here is the 800 meter. That's why the 800 meter upon time. Time is the 2 minutes, means 120 seconds. So 120 seconds. 0 gets cancelled here. 80 upon 12 meter per second. But if I want to convert it into kilometer per hour, we know that in order to convert any term into kilometer per hour, we just have to multiply the whole term by 18 by 5 kilometer per hour. If you don't know how to convert the meter per second into kilometer per hour or the kilometer to hour into meter per second, then watch the video. I have the video on that also. You can go in the speed, time and distance playlist, and there you can find the video how to convert the kilometer per hour into meter per second or vice versa. So let's see. Just remember that in order to convert into kilometer per hour, we just have to multiply the whole term by the 18 by 5 kilometer per hour. And in order to convert into meter per second, we have to multiply that term by the 5 by 18 meter per second. Okay. Now let's see here. 6 2s are 12, 6 3s are 18, 5 1s are 5, 3, 5 6s are 30. So 2 8s are 16 and 8 3s are 20. 24 kilometer per hour. So this is the upstream speed. What is 24 kilometer per hour? Similarly, we have to calculate the upstream speed, downstream speed also. So here it was the downstream case. So downstream speed is nothing but, again, the speed is equal to distance upon time. Here the distance is the 3000 meter and the time is the 240 second. So 240 second. Again 0 gets cancelled here. So 300 upon 24. Again we have to convert this meter per second into kilometer per hour. We know we have to multiply this term by 18 upon 5 kilometer per hour. So here, as we know, 300 upon 24 into 18 upon 5. So what I did here is 300 upon 24 into 18 by 5. As we know that 6 4s are 6 3s are, again the 4 7 are 28, 2 is remaining and 0 and 5. Again 5 1s are 5, 2s are remaining, 5 5s are. So 15 3s are 45 kilometer per hour. So this is the downstream speed. Downstream speed is the 45 kilometer per hour. But what we have to calculate here is x and y, means the speed of the boat in the still water and the velocity of the water. So x is equal to 1 upon 2 of sd plus su. Again 1 upon 2 of sd is 45 plus su is 24. So it will become now 1 upon 2 into this 5 and 4 9, 4 2 6. So 2 3s are 6, 2 4s are 8 and 2 5s are 10 kilometer per hour. This is the speed of the boat in the still water. Again we have to calculate the speed of the water as well. So y is equal to sd minus su. As we know, sd is 45, su is 24. That's why 1 upon 2 into 5 minus 4 1, 4 minus 2 2. So it will become the 10.5 kilometer per hour. So this is the y, means speed of the water, rate of stream or velocity of the water is 10.5 kilometer per hour. And the speed of the boat in the still water is 34.5 kilometer per hour.